Hi guys. Okay, so now we're kind of going back to one section in chapter 1, which is called section 1.5 circles. And I'm adding half circles on here because I think when you get to calculus, half circles are more important than circles themselves. So, and to go from a full circle to half circle is quite easy. Okay, so this is Mrs. Bloom, so this is my key. Okay, so definition of a circle. Circle is a set of points in the xy plane, that are fixed distance, which is called r, from a fixed point called the center, which is, we're going to use h comma k. Okay. And as you know, r is the radius. Okay, so circle is a set of points in the xy plane. Remember, in geometry, the xy plane, they extend forever, that are fixed distance, radius, which is r, from a fixed point, which is called the center. We're going to use hk for our center. Okay. We're going to come back. I think in your printed notes, the half circle is probably up here, but I moved it. So if you have the definition of half circles up here, just skip it for now, and then you're going to come back to it in a little bit. Okay. So standard form of an equation of a circle is going to be x minus h squared plus y minus k squared equals to radius squared. Okay. And as you remember, h comma k is going to be the center, r is going to be the radius. Standard form of an equation with the center at 0, 0. Okay, so if this is 0 and this is 0, then all you have left is going to be x squared plus y squared equals r squared. And in chapter or section 2.6, you saw a lot of x squared plus y squared equals 16, which that means the radius is 4. X squared plus y squared equals 9. That means the radius is 3, because to get the radius, you have to take the square root of this answer. Okay. Next, unit circle, except the radius is 1 unit. Okay. This means radius is 1 unit. That's why it's called a unit circle. So all that is going to be, is going to be x squared plus y squared equals 1 square. 1 square is just going to be 1. So the radius is 1, so this is called unit circle. All right, half circle. Okay, so what that means is we're going to take, okay, so let's just say that we're going to take this equation right here, and I want to solve for y. Okay, solve for y. So the first thing I'm going to do is I'm going to subtract x squared to the other side. So now I got y squared equals 1 minus x squared. Okay. Then to solve for y, now I need to take square root. So this is now y equals square root 1 minus x squared. But anytime you take a square root, there's a positive and there's a negative. Okay, so half circle, you can have the top half which is going to be the y equals positive, or most of the time we don't even need to write positive, 1 minus x squared. And then you have the bottom half, okay, which is y equals negative square root of 1 minus x squared. So that's half circle. Oh, you know what I should have done? Can you please switch those? This is half circle unit, half circle with the radius 1 unit. Even that is wrong. Half circle, radius of 1 unit. I got unit in there twice. Okay, so switch those two. So this is supposed to be on here. So if you have not written it on here, or if you have it written in pencil, can you please just erase and put it on there? Okay, so how do I graph that out? Well, the radius is 1 unit, so I'm just going to go 1 unit here, 1 unit here. The center is at 0, 0. 1 unit above, so this is going to be the top half circle, okay, or positive half. Okay, so top half circle or positive half. Then you have the negative half, which means this is going to be on the bottom. So unit radius is 1, so what I do is I mark 1 unit from the center, and all I do is 1 unit from, okay, so this is bottom half circle or the negative half. Okay, so that's what a half circle will look like. So now, what if the radius is not 1 unit? How would you get the top half or the bottom half? Okay, so what I would need to do is I'm gonna take the standard form here of, oops, you can't really see. I'm gonna take the standard form of a regular circle. Okay, I'm gonna solve for y. So I'm gonna do all the work up here. Solve for y. So the first thing I'm going to do is I'm going to subtract this entire piece to the radius side. Okay, so I have y minus k squared equals r squared minus x minus h in quantity squared. Okay, so all I did was to subtract this whole piece to the right hand side. Then now I'm going to go in and take the square root. Okay, so take the square root. If I take the square root of that, I have now just simply y minus k. If I take the square root of this piece, I'm going to have a plus or minus r squared minus x minus h squared. Okay, so now if I take the square root of that, oops, I'm sorry, I need to put that in there. If I take the square root of that, the square root and the radical, they're inverses of each other, so those will cancel out. So now I have this piece, y minus k equals, I should have done that right there. Okay, so plus or minus r squared minus x minus h square. Then I'm just going to add k to both sides. So I'm out of space, so I'm just going to move it up here to add k to both sides. So now I have y equals, okay, plus or minus radical radius square minus x minus h square. And then since I'm out of space, I'm going to do the plus k outside of the radical. Okay, so this does not belong in the radical. So this is the half circle formula when the radius is not 1. So the radius can be 16 square. Okay, so the radius can be, the radius can be 16. So this will be, what's 16 square? Oh, I don't even know that. Let's use my calculator to see what 16 square is. 16 times 16, 256. Okay, so if the radius is 16 units, this would be 256. If the radius is 4, then this would be 16. Okay. If the radius is 3, then this would be 9, and so on and so on. So half circle formula for that would be y equals plus or minus. Okay, so the plus is going to be the top half, the minus is going to be the bottom half, square root r squared minus, this is still under the radical, minus x, quantity of x minus h squared, then plus k on the outside. Okay. Okay. Now let's move up. And again, to keep in mind that I wrote this on the wrong spot, so switch these two definitions. Okay. And if I'm going too fast, then you know what? Do me a favor and just pause. Okay, finish copying all the definitions, then continue with example 1. Example 1. Find the standard form of the equation of each circle with the given information. Okay, this one you're given a graph. So, but you know the center right away. Okay, so if I can just count, the center is at -2, +2. negative 2, positive 2. So now I'm going to also need the radius. Okay. From the picture, I can go up 3 units. 1, 2, 3. That means the radius is 3 units. I can go right 3, okay, left 3, bottom 3, or bottom 3 and then left 3. Doesn't matter what direction you go to. Remember, it's a fixed distance from any point at all on the circle to the center. Okay, so the radius looks like it's 3 units. Okay. So based on the definition of a circle, the standard form is x minus h squared plus y minus k squared equals r squared. So this is a minus 2, so that's going to give me x minus a negative 2 squared plus y minus a 2 squared equals to 3 squared. I'm going to simplify this, leave it in standard form, so x plus 2 squared plus y minus 2 squared equals 9. So anytime the center is a negative, one of the coordinates is negative, then as you see right here, a minus and a minus will make it a positive. So when you write it in standard form, it becomes positive. Okay. Alright, so now we'll move on to example B. Again, you're gonna I'm asking you to write it in standard form. It says, hey, I'm giving you a center at 1, 2, and the circle contains the point negative 4, 3. So if you sketch this out, it's probably easier to see. So here's 1. Here's 1, 2, which is the center. And it contains the point negative 4, 3. So negative 1, 2, 3, 4. And go up 3. So this circle is supposed to have this point. Okay, so this is my radius right here. So here's a circle. Somewhere along this is a circle. Okay, as long as it has that point, I'm happy. Well, this point, okay, from this point to this point, it's not as obvious to me to see the distance. So what I'm going to need to do is find the distance of that. Okay, and the distance is going to be my radius. Okay, so that's what I'm going to find. So D equal big radical x1 minus x2 squared plus the difference of y1 minus y2. And I'm going to square that. Okay, so D again is the same as radius. So the first x is 1 minus a negative 4. I need to square that, plus 2 minus 3, and I need to square that. This is going to be 5. 5 squared is going to be 25. 2 minus 3 is negative 1. Negative 1 squared is going to be positive 1. So this is the square root of 26. And square root of 26 is going to be, what, 2 times 13. So really, I can't take it out the radical. So we're going to leave it as is, okay? So now I have to put in standard form, which is x minus h squared plus y minus k squared equals r squared. I already know what the center is, so now I just have to put it in. X minus 1 squared, and the 1 comes from the x coordinate of the center, plus y minus k. K comes from the y coordinate, so y minus 2 squared equals square root of 26 and radius squared. Okay. Well, the square root and the square power, those two are inverses of each other, so they cancel each other out. So now I just have a 26 on the right hand side. Okay. Excuse me. Alright, so if I'm going way too fast, then do me a favor, please, and just pause, soak it in, okay, and then play again. Because all I'm going to do for this lecture is to finish until the end of part D, which is not a very long lecture. Okay, so even if you listen to it twice, you're probably not going to exceed, or you're probably going to be around half an hour still. All right. Part C, find an equation of the circle in standard form with endpoints now of the diameter at these two locations. Okay, so as a visual learner, I'm just going to plot this out. Okay, I have 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is one endpoint, and another endpoint at 1. Oh, you know what I just did? I just plotted negative, huh? Ignore this point. 5, 1, 2, 3, 4, 5, and 4. So positive 5, positive 4. And I have another endpoint, 1 comma 2. So here's 1, here's comma 2. So 1 comma 2. So here is the radius of my center, okay? And if you know the radius, I'm sorry, diameter, what am I saying? Diameter equals 2 times the radius, okay, as we all know. So if I know this distance and I divide it by 2, then I will get the radius. And that's what I'm going to do first. I'm going to find the distance formula. Okay, so distance, which is diameter, okay, equals square root of, big radical here, the difference of the x-coordinates square plus the difference of the y-coordinates square. Okay, so that brings me to big radical 5 minus 1 square. Then add it to 4 minus 2 under the radical still square. 5 minus 1 is 4. 4 squared is going to be 16. 4 minus 2 is 2. 2 squared is going to be 4. So this is going to be square root of 20. Okay. Okay, so the square root of 20, what I'm going to do is, so square root of 20 is going to be square root of 4 times 5, and square root of 4 is going to be 2 rad 5. So this is currently my diameter. If I divide that by 2, I'm going to get my radius. Okay, so radius is going to be, well, 2 root 5 divided by 2 is simply going to be rad 5. So right now, this is my radius. Well, it's nice to have the radius, but what else am I missing? You're right, I'm missing the center, okay? So you can do it 2 ways. You can go and find the midpoint. Okay. And the midpoint is going to be the average of the two x-coordinates, x1 plus x2. X average means divide by 2, comma, the average of the y-coordinates, okay? So add the y together, divide by 2. So let's add. So because the midpoint will give us the center, okay? So we're going to go 5 plus 1 divided by 2, because 5 plus 1, these are the two x-coordinates, comma, 4 plus 2 divided by 2. They both happen to be at 3, comma, 3. Okay, so that's 6 over 2 is 3, 6 over 2 is also 3. So that's my center. Okay, and I can also visually check as well. If you look at this distance right here, okay, from here to here, looks like it's about 4 units apart, right? So if I go 2 units to the right, okay, and from here to here, looks like 2 units apart on the y, so then I go up, so I should be at the middle, okay, so go right 2, up 1, and that's at 3, comma 3 as well. So it checks visually and it checks algebraically. So now I just have to put it together. X minus 3 square plus y minus 3 square equals radius square. My radius is root 5 and I'm going to square that. Okay, so now I just have to take it out the radical. So x minus 3 square plus y minus 3 square equals 5. And this is my final answer for the circle. Sorry, I just need to turn my phone off. Alright. So that's what you need to do if you have 2 endpoints. Okay, so the first thing you need to do is to find the distance of the diameter. Oftentimes you can count it, but sometimes you can't, then you have to find the distance formula. Once you have the diameter, you need to divide by 2 to get the radius. Once you have the radius, now you have to find the midpoint, okay, which is the average of the 2 coordinates, okay, of the x-coordinates and the y-coordinates. Then you put it together as a standard form. Alright, last example of the lecture. Alright, now you are given a center at 3, negative 1 and a tangent to, and the circle is tangent to the line of x equals negative 2. Okay, if you remember from geometry, tangent line, okay, is the line where it touches the circle at one and only one point. Okay, so again, I'm going to plot it out. Here we go. 1, 2, 3, here's negative 1. This is my center. And this circle is tangent to the line x equals negative 2. Well, x equals a negative 2 is going to be 1 and 2. Here's x equals a negative 2, all right? X equals negative 2. And I'm supposed to touch this point 1 and only 1 point. So if I touch it 1 and only 1 point, okay, then I would know my radius right away. Okay, I can just count. Here's my radius, especially if I only need to know 1 point, and I can count 1 unit, 2 units, 3 units, 4 units, and 5 units. So the radius is 5 units, okay, by counting. Alright, so in the case that you cannot count, then you would have to find the distance between this point and this point, okay? This point you already know, which is 3 comma negative 1. This point, because x is negative 2, and if it's tangent to the circle, then the y value would be the same. Okay, so this point right here is negative 2 from this x line, oops, and the y value is negative 1 because it has to touch the circle on this point. Okay, so if you find the distance, you'll come out to be 5 as well. So since I have the distance, since I have the center, I'm just going to put it together. X minus 3 squared plus y plus 1 squared, because it's a minus of a negative 1, equals 5 squared. And 5 squared, that's going to give me 25. So I'm just going to rewrite this with 25 on the very back. Okay. And that is the end of today's lecture. Now again, if you didn't understand this lecture, please just rewind it, pause, rewind, listen to it again. Even if you listen to it again, it wouldn't take you too long. All right, have a good day or good night, depending on when you're listening to this.